Hello, everyone, and welcome to this Lunch and Learn session together with Thomas Petersen. Today, we are going to talk about hydrogen and in particular the FCWave. Thomas and I met, I think, a few months ago during the Marine
Correct.
Expo event. And as we were walking down the corridors, seeing what beautiful technologies lie in store for us, we saw this pretty non-conspicuous cabinet, I should say. So it was more or less just, yeah, to be honest, Thomas, it was a box, but we saw some hydrogen signs and other things around it. So we thought, that sparked our interest. And when we started speaking, you told us that not only was it more than a box, it contained 200 kilowatts of power inside.
Correct. Correct.
I still don't know what's in the box, but you're going to tell that to us today.
Yeah, sure will. And thank you very much for being given the opportunity to do this presentation. We got, as I understand, 18-20 minutes or so. So I've been trying to reduce my slide pack, but still get the message across. What is this technology? What is the pros and cons of it, and who is Ballard, and what is it that we actually do. Yeah. Very short introduction. Ballard is actually one of the more mature companies in the PEM fuel cell industry. It's been around for more than 40 years, headquartered in Canada. A lot of history in automotive, heavy-duty automotive, but we're definitely also looking into the likes of trains, power station, backup power, and of course also ships. We do a lot of studying. I think we accumulate roughly 400,000 hours a year in fuel cell technology development. So there is a vast amount of knowledge inside the company. We are also in control of part of our own supply chain, which of course gives us certain benefits in trying to adapt to market needs. I think one of the main subjects to get across, or main references to get across, is that we do have a vast experience from automotive with more than 100 million kilometers from products that have actually worked out on the road, and that is of course one of our greatest benefits in the design of what we're doing. Being more than 1,000 employees, I mean, we're I think currently we're growing so fast, but right now I think we're actually more on the 1,200. Denmark grew from 35 employees around 5 years ago, and so we will likely be 200 this year. So it is a growing company, but we are more than just a technology provider. We are also an engineering service, an after-sales service, and I'll definitely come back to that later. We offer training of within our products. We do have online monitoring of certain buses, so that every time they get back into the garage, we will upload the data and it'll go into our service team, and they will review the data and predict planned maintenance activities, etc. For so what can we do for marine clients? I mean, there's 6 individual phases you see here. That's the typical lifespan of a technical asset, not really only related to marine, but any technical asset. Could be a power plant, could be a factory, whatever. And it's just important for us to say that, as I said before, we are more than just a technology provider. We are also an engineering support. We are also a operation support, meaning that we have a fully manned service department. We can be, at your facility or at your quayside whenever you need us to, and we can set up a service contract, etc. So, we can take the journey with you and be there in whatever phase that your project or your operation is. And that's just a very important message to get across. So for those who are not really familiar with what is a fuel cell, it's I'll be very short about this. It's an electrochemical process in which a hydrogen atom is actually split into the proton and the electron, and the electron conducts a electric circuit, and the proton merges through a membrane and fuses with oxygen, and out comes water. That is the only byproduct of a PEM fuel cell, proton exchange membrane fuel cell running on hydrogen. It's an old technology. It's been around for decades. Fuel cells were actually used, as far as I know, in the Saturn rockets in the 60s. So it's more about, what have we done in adapting this technology into the rather conservative marine industry, because it's not been about how do we get a fuel cell to work, but how do we take this technology in a safe condition and merge that into an industry that works remotely, but also carries, a lot of value in regards to the asset, and of course also, for ferries, thousands of people at the same time. And this is the box that Vincent so kindly said that doesn't brag a lot about it, and it doesn't. I mean, this is what you're seeing here is a 200 kilowatt hydrogen fuel cell. And there's not a lot of fuss about it. It is a very discreet looking cabinet. I'll get back to the dimensions of it, but we chose to keep it that way. And I think it's a bit of the DNA of Ballard that we don't brag too much about ourselves. We're more focused on ensuring that our technology and our offerings to the market actually works more than just making it look fancy. It is, and that's very important message to get across. It is the world's first type approved fuel cell for the marine industry, and that has been a more than 3-year program to get through. Because, as I said, we know the fuel cell technology, but how do we engage with the regulatory side of the business? The class and flag state authorities, and to get their take into the design. And the outcome is that we have a system, as I said, which is now type approved and contains no less than 16 individual and sequential safety barriers. So I'd like to say that this fuel cell is as safe as any other means of energy provision currently available in the marine industry, and backup power as well, for that matter. It's a very long process to get a type approval. I mean, we have, as I said, we have spent more than 3 years, submitted thousands of pages to class. We have done all sorts of tests, including building a tilting machine and taking an operating fuel cell and stick it to the tilting machine and simply tilting this fuel cell while in operation between plus and minus 22 degrees from zero. And demonstrate that it can actually operate in such a way, because that is the environment that it will be exposed to on board a shipping. We've done inclination tests, as I said. We've done vibration tests, rattling the damn thing to see if it would fall apart. We've blown it up even to make sure that the integration would work in regards to containing worst case scenario situations. So if someone comes to you and says, we'll get a type approval in 6 months, I would just respectfully say be skeptic, because it is a very long process. It does take a lot of re-engineering, a lot of discussions with class and flag state authorities, and that's perfectly fine, because if we cannot prove the safety of the system, it shouldn't be out there. That's as simple as that. Physical dimensions, performance, etc. It is to be considered equivalent to an electrical cabinet. It's got the footprint of what we in Europe know as a Euro pallet, meaning that it's 1.2 meter wide, 0.8 deep, and approximately 2.2 meter high, weighing about a ton, 1,100 kilo in operational condition. And as I said, it does produce 200 kilowatts of electrical DC power. It does it at a voltage range between 350 and 720 is actually not correct, because 720 is the idling voltage, and as soon as you apply a load to it, it will come down at about 500 volts DC. The characteristic of a fuel cell is, of course, that it's a load follower, meaning that the voltage will drop the more you load the cell. So that's why you need a DC-DC stabilizing element in what you call the sequence of it. That's standard common practice in fuel cell technology, even in automotive and where else it's being used. It's of course being prepared for an IP44 rating in the ship industry, and I'd like to say that we'll get a bit more into that. But everything has been made accessible from the front, so that you can access all maintenance activities, which, by the way, isn't very many, and all integrator interfaces are also at the forefront of the cabinet. So you can stack them side to side or back to back, depending on what is the ideal configuration for your application. I know it's a slightly detailed image here, but just to give you an indication that, as I said, everything is accessible from the front, and we have placed all the interface access point and connections at the bottom of it, meaning that you can actually have your floor above these access point, the pipes, connections, etc., because they are not normally points or objects that you need to attend to during the operation of it. What is, of course, also important is to explain, is this any more difficult to install than a conventional diesel engine? And in principle, it isn't, because if you're involved in operating diesel engines in a ship and in an engine room, you would know that you need ventilation air in there. You need a power supply. All modern engines with electronic controllers require a power supply. You normally also have an interface to the ship communication system. In this case, our machine has two process outlets, or in principle three, but the two main ones are a ventilation outlet and a process exhaust outlet, and they are the top of the unit. You can consider them equivalent to the crankcase ventilation of a combustion engine and the typical exhaust system of a combustion engine. Ventilation is pure air. It's part of our safety system that inside ventilators or fans are drawing in air and flushing that through the entire cabinet, so that if there should, in the very unlikely event, if there should be a hydrogen leak, it will be ventilated out, and of course it will also be monitored that there is a hydrogen sensor ensuring that if we detect anything, it will shut down immediately. Okay? There's two cooling water circuits, what we call a high temperature and a low temperature. High temperature is, of course, the process heat, which is in the plus 200 kilowatts range if you're running at full load. And there's a little secondary cooling water loop for the power electronics, but normal temperature range, you can fit it into your existing LT or high T cooling water system on the ship. We need roughly maximum 45 degrees in, and we'll outlet it at roughly 65 at full load. So it's not any more difficult than conventional equipment on board a ship. And then, of course, as a byproduct of the electrochemical process, there is a liquid drain water, pure water, absolutely chemical clean water that can be either led to a tank, or it can be led to an overboard valve, or it can be led to your normal built system on the ship. So just to say that it really isn't any difficult or any more different than a conventional combustion engine. It needs the same. It needs fuel and air and communication, and it does have an exhaust, and it does have a cooling water circuit. That's really it. And as I said, you can stack them next to each other, and have a combined piping system. For the purple one is hydrogen, and the red and blue is simply illustrating the cooling water circuit. See? The rest you see down there at the bottom is the electrical outlet connections and a Hartog multi-plug connector for the communication interface. You can also stack them, as I said, kind of on a platform. We are in the development of this skid that allows you to stack them, with a number of them side to side and a number of them back to back, so that you can make a very, compressed and small power packs in the size of 1 megawatt. So 3.6 meters by 1.5 is really more or less the same as for a conventional diesel engine. So again, we are comparable in that respect. And what you can see on the top of each unit is actually the process and ventilation exhaust that I just mentioned. Now, obviously, it's important that the technical asset is also serviceable, and what we have done is we made it, in a split format, so that the bottom section of the enclosure can remain at site. It contains the balance of plot components, and that is objects that has a plus 40,000 hour meantime between repair, meaning that it can be refurbished on site whenever convenient. The top module can be separated, and we can do that within a day, so that we would actually turn up with a refurbished module and simply do a one-to-one swap, which can be done within a day, thereby preventing that your vessel has to be along a quayside for weeks while we do the major overhaul. As I said, it can be done within hours, so it can be fitted into whatever operational profile that your route is, and thereby utilizing these intervals. Total cost of ownership is, of course, also a very important subject, and there's no question that fuel cell technology is still, to be, say, demystified, because a lot of people would like to think that it's rocket science. It really isn't. But of course, there are uncertainties for someone who's not known to it. So what we can do is that if a customer or client provides us with a load profile of their intended operation, we can run into our calculations system and say, right, what is the ideal number of modules and what will it cost you to operate them based on annual hours, cost of the fuel, how much maintenance do you wish to do yourself, and how much should we take care of. And the purpose of this is really to find the number of modules that is ideal for the operational pattern. Because if you say I need 2 megawatt, I'll buy 10 units, then we would say, no, you should probably buy more, because then you will operate them at a more ideal efficiency. So, again, let us know what your load profile is, and we'll run it through our calculation tool and provide you with a total cost of ownership, which is the right balance of CAPEX and OPEX. And we will also be able to inform you when to expect certain major costs in total or major overhauls, just like you have for conventional engines. So what does it cost to operate a fuel cell? Obviously, all depending on what is the cost of the hydrogen. I think the European hydrogen infrastructure is developing. We would like to have seen it more developed than it is for right now. But I actually read this week that there will be a bunkering station in Rotterdam, so that's obviously a good start. Felixstowe, UK, is also being outfitted with a hydrogen port. So it is getting there, but it can actually be cheaper to operate on hydrogen if you can buy it as a great product and consider that to be fulfilling your profiling. It's also important to say that the marine diesel oil figures used in this little illustration here is actually outdated. It is likely in the plus $1,000 per metric ton, as far as I saw just recently when looking at the Rotterdam costs chart. And of course, can we reuse or recycle anything inside the fuel cell? Yes, we can. We can actually reclaim 95% of the platinum in the actual fuel cell stack. So we do provide a circular, recycling opportunity that ensures that we are not misusing, whatever world resources that is available. We are trying to be environmentally, responsible as well. Ships powered by our fuel cell, there is a number of them. Norway is a ferry up Norway, which is being outfitted with our units that's actually been commissioned right now. FPS is a Dutch operator of inland waterways. They are in the process of outfitting a number of their vessels with our units as well. river barge in Germany as well, and we are getting inquiries from container operators. We're getting a lot of inquiries actually from what do you call it, pleasure crafts and from cruise liners, because cruise liners are operating in environmentally sensitive areas, and they have experienced that they simply need clean energy if they are to continue their business. So a lot of focus and interest. So that was really all for me in this very short introduction to fuel cells. But here's more details. So please reach out to me if there's any further information that I can assist with. Are we happy with that? Good.
Yeah. Thank you, Thomas.
No problem. So questions?
Yeah, I have a question. Thanks, Thomas. A very nice presentation and interesting stuff. I guess you guys are a real front runner in this space. So you talk briefly about the modular skid, and what do you think is the biggest challenge in scaling this up? So you indicated a 1 megawatt.
Yeah, I mean, for now, we have built a 200 kilowatt unit because a couple of years ago we expected that would be fulfilling the immediate need for smaller vessels like ferries and so forth. And then you could stack them together and get the power that you needed. I have to admit, we are seeing inquiries in the megawatt in the 6, 8, 10 even. As late as yesterday, I was discussing with a ferry or vessel operator that wanted to have 10 megawatts propulsion power. Is a 200 kilowatt model ideal for that? It will take a number of them. That's of course, and it will have an impact of the installation cost. We are developing larger systems because we have seen that the market is there, right? But it is a substantial investment, and it's of course also what part of the market will be the most how should I say, focused on these products. We have and still see that shorter voyages between fixed ports or fixed points are the ones, because that's where you can also establish a fueling infrastructure. So I do not foresee that we'll see deep ocean cross Atlantic vessels being fueled with FCWaves for at least for the first period of time. Put it that way.
Yeah. No, I completely agree, and I think it's a very logical choice of the scale you have chosen to develop this first, because like the demand for larger systems is not there yet. That will take at least a couple of years, and then it will just start.
But again, I would be 100% honest with you that the number of inquiries, the sizes that we receive has surprised us. Put it that way.
Yeah.
There isn't. But again, if you look in Europe, there's a political will, and and at the same time there's a political pressure in ensuring that the marine industry joins the green how should I say, transition. So that on one hand you're pushing, and on the other hand you're also to some extent providing the changing.
Yeah, no, interesting stuff. And do you think that having these in larger scale, would that also improve efficiency?
I mean, efficiency is. I mean, every energy providing process will have its efficiency peak point. No question about that. And so does a fuel cell, so does a combustion engine, so does a steam boiler, and so does a turbine. It's the benefit of smaller units is that it allows us to connect or disconnect them. depending on what is your load profile. So it may be that you will need a higher amount of energy during a port operation. When you're in your ship, and once you're out of port and not operating your thrusters, but steaming ahead at a fixed speed, you could disconnect a number of them, because we can always balance to where the ideal point is in regards to efficiency. And there is an efficiency peak in the fuel cell where we would work towards that efficiency peak. The combined output of the numbers that you have, we should reach that efficiency peak.
So for example, if you're sailing your ship and you're maneuvering towards port, then you will basically in advance already start up more fuel cells, so that you are ready for for maneuvering.
Yeah. Or of course you combine it with batteries, so that whenever you have these peak loads, that you let the batteries take that energy need, so you get the best out of both worlds. Because again, it's really how do we obtain the lowest total cost of ownership in this energy system, right?
Maybe a question related to that, indeed, Thomas. How is it able to handle the peak loads? Because you have, of course, the ramp-up time, but is it really necessary to have the batteries if you want to be used for dynamic positioning, for example?
The characteristic of a fuel cell is that it ramps between its output. So you can ramp it from 20% load to 100% load, but it will take approximately 10 or 20 seconds. So you cannot block load it. If let's say you have a given amount of energy available, and you suddenly start, could be a high pump compressor or a thrust or anything, you want something that can take that energy peak and then let the fuel cells ramp up to the energy need that the system requires. But again, it's really all about what is your load profile, and are these peaks not very often, and what is the size of them, so that you can generate a battery package with a high C rating that allows you a quick burst of energy, but not a lot of energy storage, because you allow the fuel cells to manage that. And that is, we're not fighting batteries. We see them as being, that they are, they're supporting each other. Batteries and fuel cells do good together, because one provides energy, the other one can provide peak power, and they supplement each other quite well, actually.
Yeah, exactly. And maybe also the case that you don't need a very large battery if you're...
No, exactly. No, it's all about the C rating,
Yeah.
If the energy peak you have is just for a very short period. I've done some studies for tugboats, because that could be a market for us, and there's been an interest from shipyards providing tugboats, and of course they are sailing slowly around, and suddenly they need to push a larger ship, but again it's for a short period. And then they're idling again, and then they're steaming for a couple of hours, and then they're idling, and then they're pushing the ship for two minutes, with a high peak load, etc. So it's really all about how do we balance the energy provision, and we can support with calculating that.
Yeah, exactly. And I think what you also said, because you only have to bridge the gap between the ramp-up time, right? With the battery.
Exactly.
If you can bridge that, then thereafter the fuel cell is running at the capacity that you want, and then you don't need the battery anymore, of course.
And a fuel cell is, that is an electrochemical process. It's all about the getting the right mixture of hydrogen there. It's a stoichiometric process. So and the fuel cell is most efficient at the right stoichiometric volume of hydrogen available, and so it's not like we can suddenly just drop the pedal like you would do in a car or anything, and you can do it, but it will still need time to accelerate up, and it's really not fuel efficient, right? So that's why you need to balance energy and power in the right format.
Look, in that view, it's also beneficial to have a battery, for example, that you can also help in there and make it more efficient indeed. Yeah.
Exactly. Especially, with vessels that are doing a lot of maneuvering and are depending on their own thruster power.
Hey, gents, I need to run, but thanks again, Thomas, for your presentation.
No problem.
Super interesting stuff, and I will definitely ask Vincent for your details, and
Sure.
maybe at the later stage, I will reach out to you.
Yeah, you're more than welcome. Certainly.
Thanks a lot, guys, and thanks, Vincent, for hosting.
Welcome. I'll have a few more questions for you, Thomas, if you don't mind.
Yeah, sure.
Great. See you, Richard. Yeah, great questions. Some of them have already been answered, and I know a few already, but some I'm still gonna ask, especially with regards to the hydrogen storage and tanks, etc. I mean, that depends, of course, on what the client has available once in terms of pressure or even liquid. I'm assuming if you have, for example, 100, 200, 300 bar tanks, you can, I wouldn't say fill them up, but at specified or specific refueling stations, you could add hydrogen to the tanks.
I mean, provision of the tanks and piping infrastructure is really not our core business. But of course, we know who to engage with, and we know what to request. The machine itself will operate at an inlet pressure between 3.5 and 6.5 bar, and that can either come from gas, and it hasn't been a gas format. I need to emphasize that. It can either be contained in high pressure tanks, steel tanks, or also there's also composite tanks available. I think the typical pressure right now is 350 bar. We are seeing 700 bar bottles being introduced into the market, but it can also be liquid hydrogen, which of course will allow you to contain far more than if it's pressurized. It will then require a vaporizer to convert the liquid into. But for instance, one of the projects we are involved in the ferry up in Norway, that is liquefied hydrogen.
Oh yeah.
So and again, from a safety perspective, you do not need to have a 350 bar pipeline running across the entire ship from where you have the tank facility and as long as we get it in somewhere between 3.5 and 6.5, fine with us. So do your pressure regulation or pressure reduction as close to the tank as possible.
Exactly.
And that would make your safety aspect and your approval process far more easier, right?
Yeah. So you just have storage tank, then
Yeah,
you have
exactly.
evaporator or reductor,
Yeah.
and then you have the piping.
Yeah, exactly.
Okay. I love your quote about it being the same as a diesel engine. It needs the same things, and the same things go out. But you can't drink the water. But
no, well, in principle you can. Yeah. I mean, it is chemically pure. There may be, given that it's chemically pure, it probably doesn't taste that much because there are no minerals in it. But it is clean. It really is that clean, and the pH value is also very close to neutral.
I thought if you drink chemically clean water, your body gets dehydrated because it sucks all the minerals and stuff out of your.
Exactly.
That's maybe a biological thing.
But yeah, you're absolutely right. You're absolutely right. Right?
The modularity, I think that's my last question. Do you only have the 200 kilowatts unit available? You said you're working on larger ones, but is there, for instance, 100 or?
I mean, we do have smaller modules.
Okay.
The 200 kilowatt unit is the one that is currently marine approved. We can approve, or sorry, not approve. We can provide smaller units. There will be automotive products. They are as reliable as the FCWave, but they are not for now approved in the marine industry.
But you could use them for land or shore
certainly
purposes.
Yes, and we are right now in the process of developing large scale land-based power systems for data centers and backup power and electrical vehicle charging, etc. Right?
Yeah.
And Ballard in Denmark actually came from backup power in the critical infrastructure industry of telecom systems, etc. So we do have a range from 1.7 kilowatt and up to I think the largest product we have right now is in development, but it's been prototyped at it's around 1.5 megawatt, but it's a land-based system.
Check. So you're going full circle back to the
and you know, marine business looks very interesting. So does stationary power. I like to emphasize that. I mean, we are seeing a number of requests and also orders because again, some of the what do you call them? Transport companies do have a green profile.
Yeah. Cool. Maybe one more question.
Always.
Temperatures involved. There was some heat coming from the PEM cell. What are typical inlet-outlet temperatures?
I mean, the machine is built to operate in a conventional engine room between 0 and 45 degrees. The water temperature, we need water to provide it to us at maximum roughly 45 degrees. It can be 5 degrees, it can be 10 degrees, but maximum 45 degrees. And we will then outlet it from our heat exchanger at roughly 65 degrees.
Okay.
So it's not a how should I say, unmanageable heat range.
It bears striking similarities with a diesel engine that has the cooling water, of course.
Meaning that you can use it for accommodation heating or use the energy for a freshwater generator if you're operating such one, or whatever you may use it for.
Yeah. Wow, perfect. Okay. Well, I think that's it. Those are all my questions, Stefan. I don't know if you have any.
Maybe one question.
Yes,
If you're a ship owner and you want to install the FCWave, for example, how does that procedure go? What are the things that you need to hand over to you? How long does the procedure go? Because I don't think it works like that you can just order it and install it at your ship. What are the things that you need to...
We are, I mean, right now, we are building up our supply chain and our production facilities. It means that we are aiming at being able to deliver in 4 months. So because we know, but I mean the technology is there, and the product needs to be there. So that would likely be retrofit projects that would require such a short delivery time. New buildings typically has a design phase of several years. I mean, it wouldn't be any different than if you approach a class company and said, I intend to have this installed on my ship. Let's do a risk assessment. Let's do a technical assessment. What rules and regulations, compliance do I need to be synchronizing or adapting to, and we can be part of that process as well. Explain, what our safety philosophy is and how we comply with class rules. So it's really, again, it's a review process, just like any other means of technology that you introduce into a ship.
Yeah, that's quite good. Good to hear, Nick, that you can also range the whole process and that you can also choose what is the best option for them, and which things they have to cover, for example.
Yeah, of course, because I mean, as I said before, this is still a new technology in the market, not a technology itself, but in the market. So there's also there's not a lot of knowledge among class authorities and flag states, and that's fair enough. We're at the forefront here. So we try to, as I said, demystify and explain all the safety systems on all the safety functions that we have incorporated into our machine, so that we actually prove that it is as safe as any other means of energy. Yep. And that involves that we engage in a dialogue with class and flag states, and of course customers as well, which is part of our everyday.
Yeah, but that is also the impressive part that you've handled now, because you have the technology, and of course it's not really plug and play, but it is almost plug and play, because you have the unit and you only have to cover the safety, but you have already covered all the standards or the certification that you need to comply with.
we have tried to make this technology available in such a way that the inconvenience with some may see that we have actually managed that.
Yeah, exactly.
By simplifying the interfaces and make them, easy understandable and easy to adapt to.
Yeah, you make the life of ship owners easier and make the problems go away.
Otherwise, we couldn't sell the product. in my opinion, and it comes from the fact that I worked my entire life in marine and oil and gas. I've been on the asset owning side of the business, so don't come and promise or present something to me that makes my life difficult to do. So that's very much the DNA that we engage with customers. We try to understand their world and not just say, here's a fuel cell, it's really fancy, but we can't support you in what to do with it. No, that doesn't fly.
Yeah. Great. Well, I think that's it.
Well, you know where to get me. So
absolutely, and as you heard, you probably get some questions afterwards.
No problem. So it's been a pleasure.
Perfect.
Good. And
thanks for your time,
Thomas. And thank you very much for reaching out to me. I'm really pleased that you dropped by at the exhibition in Amsterdam, and that we managed to get in dialogue again, and allowed us the possibility of presenting this. So thanks from my side, certainly.
Likewise. Have a great day.
Thank you. Cheers. Bye.
Bye.
See you.